Ever designed a computer chip? Me neither.
But microelectronics engineering, that's diving headfirst into circuits so tiny they make a grain of rice look massive. And we've got an expert with us to help us navigate this microscopic world.
It's true. The scale we work at is mind-boggling.
So today's deep dive, it's all about what it really takes to thrive as a microelectronics engineer. And we've got career guides, industry insights, all that good stuff.
We're talking about designing and developing the brains inside your phone, your laptop, even your toaster. Microprocessors. It's a field where you're shaping the future of technology, quite literally.
Okay, shaping the future, no pressure there.
But let's get specific. Design and development, our sources mention it a lot.
What's that actually look like day to day for a microelectronics engineer? Lab coats, clean rooms, all that.
You hit the nail on the head with the clean room.
This isn't your average desk job. Think
Yeah.
controlled environments, specialized equipment.
You know, the whole 9 yards, just to make sure that a speck of dust doesn't mess up these intricate circuits. And yeah, design and testing, that's a huge part of it, but there's also a surprising amount of collaboration.
Collaboration. I mean, it makes sense. These chips aren't being designed in a vacuum. What kind of teams are we talking about?
Absolutely not. You're working with other engineers, of course, but also material scientists, software developers, you name it.
Wow.
Even product designers. It's about integrating this tiny creation, your chip, into a larger system, and that takes communication, problem solving, you know the drill.
So these soft skills we always hear about,
Yeah.
it's not just a bonus, it's essential. Our sources really hammer that home. Complex problem solving, critical thinking, as important as the technical stuff.
Couldn't agree more. You could have all the textbook knowledge in the world.
But if you can't explain your design, can't work in a team, or troubleshoot when a problem pops up, you won't get very far.
Makes sense. Let's be real, though. This field, it's known for being incredibly demanding. The Bureau of Labor Statistics, they predict slower than average growth, 2% from 2019 to 2029, which honestly, it's a little discouraging. Should aspiring engineers be worried?
It's a natural concern.
Here's the thing about those statistics. They're looking at the whole field, but the demand for highly skilled engineers, those who can adapt to what's new, that's very high.
I see.
Think about it.
Yeah.
Everything is becoming smart these days, and that requires innovative chip design.
We're not just talking smartphones, laptops anymore. It's everything.
Yeah.
Electric cars, medical devices. You even said it yourself, our toasters. That must be, I don't know, exhilarating, but maybe a tad overwhelming if you're just starting out.
It definitely keeps you on your toes.
The landscape is constantly evolving, and that's why all our sources, they really emphasize lifelong learning as key to success here. It's true, lifelong learning, it's not just something people say in this field. It's really how you survive.
Right.
Like one of our sources mentioned, joining organizations like the IE,
Okay.
the Institute of Electrical and Electronics Engineers.
Right.
That's a fantastic way to stay updated, go to conferences.
Yeah.
Honestly, it helps you realize you're not the only one trying to keep up with all this new stuff.
Right, because who wants to be that engineer recommending last year's tech when the next big thing is launching?
Yeah.
Not a good look. But speaking of new tech, let's talk about what sparks that innovation. Our sources, they're a bit vague here, just mentioning design a microprocessor. Can you give us a real-world example? Like, what's a challenge a microelectronics engineer might actually face?
Sure. Let's take something everyone's thinking about these days. Battery life.
Okay.
Imagine you're designing the power management IC for like the next generation of smartphones. And your goal is to make that battery last twice as long. But you can't use any more physical space inside the phone.
Oh, wow.
That's a puzzle.
Yeah.
You need technical skills for sure, but also some real creative problem solving.
That sounds like it'll make your brain sweat a little bit. You've got the limits of physics, what the market actually wants, and I'm guessing a deadline breathing down your neck. How do you even start to untangle a problem like that? What's the process?
It's a back and forth between theory and actually doing it.
Okay.
So you start with simulations, running tons of models, seeing how different choices you could make, how they affect how much power the chip uses. Then you go into the lab, you build prototypes, test them like crazy, and you're going to hit roadblocks. That's just part of it. That's where that whole collaboration thing comes back in, bouncing ideas off your team, maybe even going back to the drawing board a few times.
So it sounds like a real roller coaster.
But I bet the reward, seeing your design in a product that millions of people are using, that's got to feel amazing.
There's nothing like it, honestly. And it's not just smartphones. I mean, this field, It's everywhere. Think about medical devices.
Oh, right.
Microelectronics engineers, they're working on implantable sensors
Really?
that can track your heart rate in real time or even deliver medications.
That's mind-blowing. It's like science fiction is becoming reality, and microelectronics is what's making it happen.
Exactly. And it's not even just about doing what's technically possible. It's about using tech to solve real problems, like
yeah.
renewable energy.
Okay, yeah.
We're trying to build a future that's more sustainable.
Right.
The need for energy-efficient electronics, it's only going to grow.
So instead of designing a chip for the latest gadget, you might be designing one that helps power a whole city with solar energy.
Exactly. Or one that makes electric vehicles something everyone can afford. The possibilities are huge, and that's why it's so important for new engineers, people just coming into this field. They need to figure out what really excites them about.
Find your niche, right, within this world of like microscopic circuits.
Exactly.
But it can't all be smooth sailing. What are some of the downsides?
Our sources mentioned, like, high competition, always having to learn. What's that really look like day to day? It's like you're running a marathon, but the finish line, it keeps moving further away every time you take a step.
That's a really good way to put it. The learning curve, it never really flattens out, especially in a field where everything changes so fast. You're always catching up to the latest thing, learning new software, seeing how far you can push things.
Which can be exciting, but also pretty exhausting, I imagine.
It definitely takes a certain kind of person to do well in this kind of environment. You gotta be someone who's curious, likes to solve puzzles, and isn't afraid of things being, a little uncertain sometimes.
Not the kind of person who freaks out if their code doesn't work the first time.
Exactly. Resilience, being able to adapt, and a whole lot of perseverance, that's what you need to really make it here.
Sounds like a path that really tests what you're made of. But with all this talk about pushing boundaries, are there any limits to how tiny, how powerful we can make these microchips?
That's the million-dollar question. Keeps researchers up at night.
Really?
We've been hearing about Moore's Law, how it's going to hit a wall, and we're not quite there yet, but it's true. We're entering a whole new era.
A new era? How so?
Well, think about it. For decades, we've just been squeezing more and more transistors onto these flat pieces of silicon.
Right.
But we're getting to a point where physics itself is like, hold on a second.
So what's the alternative?
That's where it gets really cool. Researchers are looking into all sorts of crazy new ideas like 3D integrated circuits. It's like stacking chips on top of each other, a high-tech skyscraper.
3D chips? That sounds like something out of a movie.
It does, doesn't it? But it's a real thing. People are working on it. And then there's quantum computing, which could totally change things like medicine, materials, even AI.
Quantum computing. Okay, now that's a whole other deep dive we need to do.
It is. But the point is, even if our traditional way of doing microelectronics hits a wall, there are totally new paths to explore.
So it's not about hitting a dead end. It's about finding a new maze to get lost in.
Exactly.
Yeah.
And that's what makes this field so amazing. It's always changing, always pushing us to think differently and see how far we can go.
For someone just starting out, it's got to be both intimidating and incredibly inspiring.
Totally. But if you're into tech, if you're a problem solver, if you're not afraid of a challenge, this field could be the perfect fit.
Well said. And on that note, it's time for us to power down this deep dive into the world of microelectronics engineering. We've covered a lot of ground, from clean rooms to quantum computers.
But remember, this is just the start. There's so much out there to learn.
So keep those questions coming, keep learning, and who knows, maybe you'll be designing the chips that shape the future.
Now, wouldn't that be something? Thanks for joining us on this deep dive, and until next time, keep those circuits firing.